Good morning, ladies and gentlemen. Welcome here at the group exhibit Hydrogen Fuel Cells and Batteries. I would also like to say hola, good morning, hello, konnichiwa, ni hao to all our online guests. We are live streaming from the fair to all over the world, so it's not only you sitting here, but also our international guests. Please come and have a seat. We are providing you with complimentary drinks. There are two lovely ladies there walking around and serve you with complimentary drinks. Also, you can raise your hands if you have a questions, and I will come down to you. So on this stage, I have two important guests that I would like to introduce to you. On my left side is Professor Didwania, the CEO of Green Hydrotec Inc. He's holding a PhD in catalysts. He's specializing in catalysts. And on his left side, I would like to introduce to you Hemant Didwania, the sales director of Ventos Compressors. Welcome here on stage.
Thank you.
So the topic for today is on-site production of hydrogen from methanol. I have a question. Why hydrogen? How do we produce hydrogen from methanol?
Okay, I was sitting here all morning. Most hydrogen produced in Europe seem to be electrolysis of water. I haven't heard about using methanol as on-site hydrogen production to hydrogen. And most of people, you are interested in electrolysis of water to hydrogen. I have no objection on electrolysis of water except the efficiency is too low. If you consider thermal energy as a primary for electrolysis to electric power and then electrolyze the water to hydrogen, it's only about 20%. Or even less if you're from wind, it will be maybe 10%. I'm going to introduce the methanol. We are talking about 70% efficiency from thermal energy from fossil fuel to hydrogen. So the efficiency is much higher. Then I would discuss why we use methanol. The methanol is available from many sources, such as agricultural waste, municipal waste can be converted to hydrogen. Actually, we are in Taiwan. We are now planning a municipal waste to hydrogen plant. So besides these two waste biomass, you can use coal or, of course, natural gas. And importantly, can be used from any heavy oil, like a diesel oil or fuel oil. When they are phased out in 2040, what happened to the oil industry with lots of investment and lots of employment after 2040, what they will do. So methanol can succeed this industry in employment, in economic activity. So this is important for methanol because it's available from any other source. This is one reason. And the second reason, the cost of cutting CO2 by methanol is much cheaper than by any other source. Experience in US and in Germany show that to reduce 1 ton of CO2 by wind energy is about 100 to 200 European dollars. By photovoltaic, it is 550 to 1870 European dollars. In comparison, in US, it's $20 for natural gas to reduce 1 ton of CO2. So you can compare. The cost of reducing CO2, it is only about 10% to 2% of the so-called zero energy wind or photovoltaic. So it is effective to reduce CO2, but much lower cost. This is my second reason. My third reason is methanol is a liquid. You can store, you can ship by any conventional ordinary equipment without special, like a cryogenic for natural gas, like special equipment for the photovoltaic. We don't need that. And for methanol, it can be used for any drum or any truck can be shipping, can be stored. Finally, methanol, many people think about toxicity of methanol. Actually, methanol is not that toxic. OSHA, Occupational Safety and Health Administration or U.S. government regard methanol as a safer fuel than gasoline and diesel oil. So it is not as toxic as people is thinking about. Finally, methanol can be converted to hydrogen, and hydrogen can be converted back to methanol. And through hydrogen, you can convert to electricity. Therefore, methanol can be converted to electricity by reversible process very easily. So methanol is an energy carrier. It's not just a simple fuel. It is a carrier for energy storage or energy conversion.
Okay, thank you very much, Professor. So what is very interesting here, and is not really something that I've heard about yet, is that so some people on this sphere think the only way to get hydrogen is by using electrolyzers. But Professor has the idea to use the methanol and get hydrogen out of methanol. Methanol is much easier to carry, it's less hazardous. But I would like to know what are the other advantages of methanol usage compared with common hydrogen storage technologies?
Okay, methanol, to produce methanol to hydrogen, it's 260 degrees, very low temperature. And it is a very simple process, much simpler than any other process. The energy requirement to convert methanol to hydrogen in theoretical calculation is 2,500 kilojoule. In comparison, for natural gas, it's 5,000, 2 times more. For electrolysis, it's 18,000. So 7 times more energy needed to convert for hydrogen production for 1 cubic meter hydrogen. So it is much cheaper in energy consumption. Third, it's very low cost. The methanol reformer to hydrogen investment cost is about 50 to 60% of natural gas process. And the production cost, including the raw material cost, is only about 80% of the natural gas route. So it is low-cost process and a simple process. It is so simple that in the future fuel cell industry requirement, you can employ part-time worker instead of experienced professional. You use a part-time worker to operate the process unit, and it is when you use on-site production, you don't have the large volume of hydrogen storage in the crowded areas. It is very important. Safety is improved. Otherwise, you have to store a lot of hydrogen in the crowded area. And finally, it is reduced about 40 to 60% of shipping compressed cost when you buy hydrogen from industrial gas company, because you don't have to store, you don't have to ship, you just produce on site.
So we just talked about all the advantages of methanol, using methanol as an energy carrier to produce hydrogen. Now, my question is, what do we need to get the hydrogen? Do we need, what kind of technology do we need? What is this?
Okay, this is the reformer, methanol reformer I use. Actually, this was the actual model for an industrial company. They want to make fuel cell for computer about 10 years ago. That time I made. This one makes 300 liters per hour hydrogen. And the unique on my company's reformer is we use catalyst to heat up. So
No, wait. First, we got to clarify this for everyone. So this is, of course, a tiny one. This is a reformer. So what do we inject into the reformer?
So we put the methanol as a fuel at the center, and with two holes down this two tube. So with two holes down here, we put catalyst in and heat up the reactor. Then the methanol water goes through side to make hydrogen. 300 liters
So we
per
put
hour.
methanol inside a liquid, and then voila, we get hydrogen outside. Sounds like a magic machine. But you just mentioned you need negative 260 degrees
260 degrees.
to run this. But how can I heat this up?
Yeah, we use catalyst with methanol as a heating. So our catalyst is so reactive, we can start up the liquid even 0 degree. In this reactor, about 3 minutes, 260 degrees. In larger reactor, 10 minutes to 15 minutes, we start producing hydrogen.
It's very
fast.
interesting. Usually it takes, sometimes it takes several starting hours to start a reformer. So you can just start within several minutes or just with less than an hour?
In a larger one, when I'm talking 10 cubic meter or 20 cubic meter, we use about 1 hour to make hydrogen. In comparison, our competitor need about 3 hours, 5 hours, 10 hours to make hydrogen. So you have to wait a long time. We don't. We that 1 hour, we start making hydrogen. In this one, 10 minutes. Yeah.
And this is just a small reformer. What's the size of your reformer? What is the size? How large is your reformer that you have developed?
The largest reformer we now make is 30 cubic meter with PSA purification. It is 1.7 meter high and 1.3 meter wide, 1.1 meter deep. So very small. It's a cabinet, not like this one. It is. We are 1/10 of that one for the same volume, so much smaller in our unit. Yeah.
And what's the duration of your reformer? How long?
Working life.
Okay. Because we use aluminum reactor, we use catalyst to heat, so our thermal management is very excellent. The efficiency is 85% to 90% efficiency. And we have been testing in our plant for 20,000 to 30,000, 33 years without any problem. Continue making hydrogen on off every day. And stable, our hydrogen is 6.9, not just 4.9, 6.9 purity. And the CO, we guarantee 0.5 ppm, but actually in measurement it's 10 to 50 ppb. So when I talk to Air Product in Taiwan, I say our reformer make hydrogen after purification is 15 ppb. They do not want to believe, so they come to measure 20 to 30 ppb. So we are guaranteed to 0.5 ppm, 500 ppb, but actually it is under 50 ppb.
So your technology has already been proven to work successfully for 18 years already. This exists. I have a question for Mr. Didwania. So you have partnered up to work together. You have discovered this unique technology by the professor. I would like to know in which application fields and in which markets do you think the reforming technology producing hydrogen from methanol will be most successful?
Well, thank you, Mona. Can you hear me? The small technology for the methanol reformer developed by Professor Ray is extremely useful to a wide variety of industry, like chemical industry or even for the automobile refueling stations. because we all start with very small refueling stations and then go up to the larger ones. So having a methanol reforming technology on site reduces, the electric load. You virtually don't need an electric load over there, and you can upgrade by adding modules as your demand grows.
Yes.
Then there is application on board. You can have this methanol reformer on board on boats, ships, buses, trucks, to simultaneously be charging the lithium-ion batteries as the vehicle is moving. And besides that, every kind of industrial application for, in the steel industry, anywhere you need hydrogen, it can be very easily produced, very quickly, very safe.
So anyone who needs hydrogen can use the reforming technology just using methanol, especially if you're off-site or on buses, because methanol is less hazardous, has lighter weight, can be easily carried. And I've seen at your booth that I visited that there is a bus model where you showed how you can use the reformer. You just inject methanol, use the reformer, get hydrogen. But then I saw a fuel cell that we need. So do you also have fuel cells?
We do not make fuel cell, we just make the hydrogen reformer. But to charge the lithium-ion batteries on the buses, we need power. For that, we need a fuel cell.
Yes.
So the bus company or the manufacturer of that vehicle can decide which fuel cell to use.
We are almost running out of time. So are there any questions from the audience? If not, you can take your questions to the booth. Both of them are very happy to answer your questions. Who should visit your booth? Who should come and talk to you?
I would say anybody who's interested in knowing more about the methanol reforming technology, Professor Ray is available with us for the next 2 days. He will be happy to answer all questions, and we can discuss applications or any other points that the people may have.
I will quickly run down to you and take your question.
Thank you very much. Just one question. The creation of hydrogen from methanol is, to me, just a conversion. The methanol is a carrier of hydrogen, and if you compare that to, for example, an electrolyzer, that is a totally different story. If you want to have renewable hydrogen, you have to create the methanol first, and then you can convert methanol to hydrogen, which means the energy that you need to first create methanol and secondly convert methanol to hydrogen should be compared to the alternative of using an electrolyzer. You said the energy for converting hydrogen or for converting methanol to hydrogen is very low, and the energy to create hydrogen with an electrolyzer is very high. But if you want to create renewable methanol, you need an electrolyzer also.
What's your question?
Well, the question is, why is the energy to create renewable hydrogen from methanol low? Because renewable hydrogen needs to be created first, also in the methanol.
Yeah, the hydrogen from methanol is much lower than from natural gas because it's already partially oxidized by oxygen inside. Methanol is CH3OH, so the carbon already attached with oxygen, one oxygen. To make CO2 is half away, so energy cost is half away between methane, which has no oxygen attached. So they spend 5,000 kilojoule per cubic meter hydrogen production. We need only 25. For electrolysis, it's even higher, 18,000. So methanol is lower energy requirement, much lower than any other process.
I think I will just add.
I think the question needs to be discussed in detail together after this interview, because the question is a very important question. The question was regarding how we can, the energy to produce methanol will be in total much higher. So we should discuss that later on. Unfortunately, we are already over time because upcoming is the press conference. We'll have a panel discussion. So thank you, Professor Rai, and also Mr. Didwania. Thank you for having you here. It's a pleasure. Visit their booth. It's very entertaining and very informative. The booth number is D54-1. Once again, thank you very much for having you here.
Thank you, Mother. Thank you.
Thank you very much.